Hello dear friends, and welcome once more to this video in our YouTube channel. In this video, friends, we shall be looking at the problem we have here on screen, guys. It's a question that looks very difficult, but friends, I promise to make the entire problem very easy for you. But friends, if you're new to this channel, please make sure you hit that subscribe button and turn on your notification icon to get notified each time we upload new videos, friends. And please consider giving the video a thumbs up. Just a thumbs up will go a long way, friends, because that does motivate me. It tells me that you found the content useful. Thank you very much, guys, and let's dive straight into our video today. Welcome back, friends. Let's have the equation on screen. That's it. We have x raised to the power negative x over the natural log of x equals the square root of x into the square root of x keeps on going forever. So friends, in such a case now, we may want to simplify the right hand side, because if you don't simplify, friends, the equation is going to look extremely difficult for you guys. It's going to look extremely difficult because when we have a function that keeps on going forever, guys, it becomes very tough, very difficult for us to solve the value of x. So in this case, guys, let's take it bit by bit. Like I said, guys, I promise to make the concept very easy for you. Let's look at the first x. It is enclosed inside of instead of 1 square root, right? Good. So we can write that as x raised to the power 1/2, right? Great. And the next x, guys, is enclosed inside of where 2 square roots. You have the original square root and its own square root. So that is x to the power 1/2. That's the power again 1/2. So we're going to have x to the power 1/4, which keeps on going forever. So friends, if we observe the pattern that it changes, we are going to see that the next term is going to be x raised to the power 1/8, and the next has to be x to the power 1/16. Great. Now, according to our law of indices, the bases are the same. We can simply add their exponents. So we are therefore going to have x to the power negative x over natural log of x equals x to the power 1/2 plus 1/4 plus 1/8 plus 1/16 plus dash, guys. It keeps on going forever. Great. All right, friends. In this case, we can see that the power of the right hand side, sorry, that's the power of x here. The sum of all these powers, guys, can form a geometric series whose first term is 1/2 and common ratio still 1/2, right? Great. So we can write this as x to the power negative x over natural log of x equals to x raised to the power the series as n starts from 1 to infinity of 1/2 raised to the power n. Keep in mind that when n becomes 1, we have the first term to be 1/2, n becomes 2, we have 1/4, n becomes 3, we have 1/8, and so on and so forth. Great. So friends, we can see that the top, like I said, guys, is a geometric series, right? Great. And as such, we have to compute all the terms that make up this series. We have to start from n equal to 1 to infinity. But friends, this is just like finding the sum to infinity of a geometric progression, and we all know it is the first term over 1 minus the common ratio. The first term is what, guys? 1/2. The common ratio is still 1/2. So we're going to have 1/2 over 1/2, which gives us 1. That therefore implies this our equation now can turn into x to the power negative x over natural log of x equals just x raised to the power 1. Good. But friends, we have succeeded in simplifying the right hand side, right? Let's observe the left hand side, guys. We can write this x as what, guys? As e raised to the power the natural log of x, right? Great. So we can write this one as e raised to the power the negative. Since this negative here, we can take it inside. We have negative natural log of x, all that raised to the power x over natural log of x. But friends, this natural log of x can cancel with one outside, right? That is, the one inside can cancel with one inside. So we're going to have x raised to the power negative, that's e raised to the power negative x equal to x. All right. So friends, in this at this point now, if we may want to investigate if this our equation actually has a solution. By that, guys, let's simply observe the graph. Okay, let's observe the graph of e raised to the power negative x and the graph of x of y equal to x, and see if they can intersect at any point. All right, let's have the vertical axis. We are going to call that y. Then the horizontal axis, we can call that x. Good. This is going to be the origin. Now, friends, let's look at the graph of e raised to the power negative x. So this is how the shape is going to be, guys, and it's going to touch the y-axis when x is 0, right? So it's going to pass where we have y equal to 1. This is the graph of y equal to e raised to the power negative x. All right. Then friends, let's now look at the graph of y equal to x, which simply bisects the Cartesian plane into two equal halves. So friends, we can see that these two curves intersect, right? This is the exact point in which these two curves are going to intersect. This is it, guys. That therefore means that this our problem has a solution. Now we still now to find the exact solution, okay, not approximate solution, because we can approximate what the solution can be, but we want to get the exact solution in its exact form. So in this case, guys, if we multiply both sides by e raised to the power x, we invert and we reverse the equation, we are therefore going to have x e raised to the power x equal to 1. Great. In this case, guys, we see that the problem becomes difficult at this point, right? Difficult at this point, since it is possible to multiply x and e raised to the power x and get 1. But what is that x value now? That is what we don't know, guys. It is time for us to use one of the powerful tools in mathematics that we know, which is known as the Lambert W function. Great. At this point now, all we seek to have is just e raised to the power some function and have that same function multiplying the e raised to the power that function. By that, we can use the Lambert W function. So in this case, we are going to take w on both sides. When we take w on both sides, we're going to have w into x e raised to the power x equals to the w of 1. Like I said, guys, where w is the Lambert W function. Wait, at this point now, since we have taken the w on both sides, now the output of this guy now simply gives us our x. That means our x now is therefore going to be the w of 1. Good. So friends, this is the final answer of this problem. Okay, this is the final answer. You might decide to get an approximate value for this by simply just going to Wolfram Alpha, guys, and punching this out. Is going to give you some decimal value. Okay, but we don't want that. We don't want decimal values because they are approximate values. We want exact values. So friends, that is it for our video. That is it, guys. Thank you so much for watching the video. Thank you so much, and please subscribe to the channel if you're not subscribed, guys, because you're going to miss out a lot of our interesting content. Thank you so much, and have a blessed day.